So this project is a joint project which was supported by Queensland Government, KBR, Siemens, Neste Oil and Cement Australia, and as well as UQ, Karlsruhe Institute of Technology and the University of Bielefeld. The idea really is to bring together biologists and engineers to conduct high quality science to develop high efficiency systems for the production of algae. And so what you have seen is that we have basic open pond systems which are relatively cheap and an established technology, but they also have relatively low productivities and high rates of evaporation. And they're not terribly good at getting sunlight into the ponds because they're about 30 centimeters deep, and if you have a dark green solution there, then that's a bit of a problem. So the more advanced systems that you see here have a much larger surface area to volume ratio, so we have thinner tubes, and as a result you get a better distribution of light energy through these systems. So this project is all about doing high quality work in the areas of biology and engineering, bringing those together to try and develop more economic systems for biomass production from microalgae. So the reason we produce algae is to produce the biomass, and the biomass is largely made up of protein, carbohydrates and oils. And so you can, in its simplest form, you can harvest the algae and centrifuge them down or harvest them in some other way, and you get an algae cake, and that can be used for a whole range of things such as animal feeds or fish feeds, poultry feeds, those sorts of uses. That's the very simple basic approach. Then you can go to making high-value products. You can extract things like carotenoids, beta-carotenes, which are used for colouring salmon and other things in the food industry. Or you can extract the oils for the production of aviation fuels or biodiesel, which you can use in your car. You can extract the carbohydrates for the production of ethanol and fractionate a whole range of other products. So really it's about making it for food and for fuel and for chemical feedstocks. So another use for algae is for water treatment. So algae take nutrients out of the solution when they grow, and so this is a way of using wastewater for the production of something useful in the form of algae biomass. So one thing that people don't realize is that there are a lot of renewable technologies out there, and people often ask, why do we use algae rather than wind or wave or solar photovoltaic? But the issue is that globally about 80% of our energy is used in the form of fuels. And all the other renewable technologies such as solar and wind and wave are targeting the about 17–20% electricity market. And so we're targeting that larger 80% market for fuel production. Technology drivers for this are that we currently have about 7 billion people, and we're going to about 9 billion people by 2050. And they will all require more food, more fuel and chemical feedstocks for the productions of things like plastics, etc. But they'll also require more water, and the estimates are that we will require about 70% more food, we will require about 50% more fuel and about 30% more water. And as you can see from these sorts of systems that they have a lower level of evaporation, so most of our water losses are in agriculture. And so these sorts of systems save on water, but they also produce products for both food production and fuel. Now there's been quite a lot of concern about first generation biofuel systems like corn ethanol, and there was a sort of a food versus fuel debate there. And what we're trying to do is move from a food versus fuel situation to a food and fuel future.